Bismillahirrahmanirrahim. Assalamu alaikum. My name is Hasib Akram, and here is my team for final year project, which includes Fariha Ahmed, Abdur Rahman, and Hamad Hassan. The topic of our final year project is effect of nano-graphite on durability properties of rubberized concrete, supervised by Dr. Rana Faisal Tufail. Here are some of the topics we will discuss. First, introduction. The problem arises as the production of waste is increasing in the recent years and its disposal becomes a major problem. Nowadays, world is moving towards sustainability through waste recycling. One of those wastes include rubber waste that usually comes from used tires in a huge quantity. Due to its complex composition, it is very difficult to recycle and its recycling procedure requires a lot of financing. Similarly, the use of natural resources like the aggregates are also affecting our nature and environment in a number of ways. To replace them with another resource or waste product without losing concrete's properties is a great solution. Many researchers replaced a small portion of fine or coarse aggregates with crumb rubber. By testing, we concluded that up to 5% replacement won't affect concrete strength, but beyond 5%, concrete strength decreases rapidly due to decrease in its density. That is actually due to the inert behavior of rubber particles.
The main objective of this project is to check the effect of nano-graphite on rubberized concrete. From research, we came to know that adding rubber in a concrete decreases its compressive strength. So we want to check that can we achieve the same strength equal to the conventional concrete by adding nano-graphite. Decreasing strength by rubber and increasing strength by nano-graphite will ultimately give a strength equal to the conventional concrete. We want to check this statement from our research that whether it is correct or not. The use of a rubber against natural aggregate will preserve natural resources. It will lower the cost of a concrete as the crumb rubber is more economical than natural aggregates. The use of a nano-graphite will increase the mechanical and durability properties of the concrete. Although nano-graphite is costly, but the use of its small quantity and greater effect on concrete properties makes it better product for a rubber recycling.
The procedure of our experimentation is same as of conventional concrete. All of these steps are shown here. Mixing procedure takes almost 4 minutes, and after that we pour fresh concrete into slump cone for slump test and then into molds and left them in air for 24 hours. After that they are demolded and then placed in water for 28 days for curing. Then molds are taken out from curing tank and their surface is cleaned from sand and debris. The specimens are then placed in the required testing machine and then load is applied on it. For studying the mechanical properties of the concrete that we are making, we selected few tests which include slump test to check if its workability is affecting by changing the quantities of rubber and nanographite, compressive strength test, FLEXURAL strength test, and tensile strength test to check whether nanographite is increasing the strength as we expected or not. Along with that, we are also doing impact resistance test to check whether nanographite will affect the impact resistance properties of rubberized concrete or not. As our testing is still incomplete, that's why we are expecting that these properties will increase on the addition of nanographite.
Project Demo. For impact resistance test, a steel ball is dropped from a certain height according to the standard onto the specimen. The specimen without rubber fracture in one crack, while the specimen with rubber penetrates the impact in different direction and minimize its effects. That's why the cracks appear in different directions. By adding nanographite, we want to check whether this property of rubberized concrete improves or not. The compressive strength test is usually conducted to investigate the compressive strength of concrete. This graph shows us that the compressive strength of concrete decreases with the increase in the percentage of rubber. The tensile strength test is usually conducted to investigate the tensile strength of concrete. The graph here shows that the tensile strength of concrete decreases with increase in rubber. The flexural strength test is usually conducted to investigate the flexural resistance of concrete. This graph shows that the flexural strength of concrete increases with the increase in the percentage of rubber. By adding nano-graphite, we want to check whether these properties of rubberized concrete improves or not.